Okay, then I'm going to keep rocking and rolling. So the only thing that we haven't covered from this section that will be on the test is the piecewise function. So I'm going to cover that, and this won't take long at all. So let me see where I'm at about right here. Okay. Right there. So. Okay, a piecewise function. Now, what a piecewise function does is it splits apart the graph on its domain. So we have two different functions depending on where our domain is located. So I'm going to start with a very basic example. We'll do a real world example here in a minute. But a basic example would look like this. Let's say we had f of x equals, and then we'll do two functions. Let's say we've got 2x plus 1. And look, the next part gives everything away. So let me make sure. Yeah, your book actually even uses the if notation. If x is, let's say, less than 3, okay? Actually, you know what, guys? Hold on. Let's say x is 1. It'll be easier to graph. And then we're going to do, let's just give it a constant like 5. If x is greater than or equal to 1. Okay, so we're going to use this top function if our x value is less than 1. And then we're going to use the bottom function 5 if x is greater than or equal to 1. So the question will give you, let's do like an ABC type question. I'll do like A. Find f of -3. Okay, find f of -3. Now remember from the function notation section, that f of -3, that means x equals -3, right? So remember, this is our x value. So x equals -3, that's what it's telling us. And then we've got to decide, okay, well, do I want to use, or does the function tell me to use the top function or the bottom? Well, x is -3. -3 is less than 1, right? -3 is not greater than 1. So because x is less than 1, -3, we're going to use the top function. So 2 times -3 plus 1. I didn't mean to parentheses it. Okay. So the x value tells you which function to use, the top or the bottom. Okay. So -6 plus 1, this gives me a -5. Okay. So then let's do another one. I'm going to kind of make my x's get bigger. So let's say we've got f of 0. Well, what would we need to use for f of 0? Well, again, 0 is still less than 1, right? 0 is not greater than or equal to 1. That would be a false statement. So because x equals 0, we're going to use this top function. 0 is less than 1. So it would still be 2 times 0 plus 1, right? That's just a positive 1. But then at 1, it switches, right? So if I asked you, well, what about 1? Well, 1, it goes from the top function to the bottom. Now, look, x equals 1. So therefore, because x equals 1, we would use the bottom function. 1 is greater than or equal to 1, right? 1's not less than 1. So we'd use the bottom function. Well, there's nothing to plug in here. It just equals 5. Okay. I'm going to choose some other number bigger than 1. Let's do f of 3. Okay. F of 3, same thing. 3 is not less than 1. 3 is greater than or equal to 1. So therefore, it would be 5. So look, whatever x value is given, it's going to be, I think they call this like dichotomous, where you're going to choose one or the other, okay? It's not going to be both. You won't have x is less than 1 and x is greater than 0, right, where you have overlap there. There won't be overlap with this changing of the domain. It definitely switches at 1, okay? Let's graph this to kind of see what's going on here. Now we've got y values that go from -5 to 5 and 1. And then we've got x values that go from -3 to 3. Okay, this won't be too bad. Okay. So we've got 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. We got our x's, we got our y's. Now we're calling y f of x now, right? That's a fancy way of saying y. And then I'm just going to graph the points here. So this first function, which is just a nice linear function, right? 2x plus 1, just a straight line, -3, -5. So when x equals -3, we're at -5, right? And when x equals 0, we're at +1. Okay? But then when x equals 1, we move over to 5. 1, 5, right? And then at 3, we're also at 5. Okay? So just to kind of show what's happening, I want to know where this line to the left is headed. I know to the left it's headed to, down here, but it's got to stop somewhere. It stops at 1, but it doesn't include 1. So if I plugged in 1 to this top one, now I know we're not supposed to because x is less than 1, right? But I want to see where it stops. If I plugged in 1 here, I would get back 3, right? 1 times 2 plus 1 is 3. So what's happening is this is headed to 3, but if there's going to be an open circle there, okay? That's a straight line. I know it doesn't look like it, but that's a straight line. So this first line, which looks like this, okay, it's this nice straight line. It's got a slope of 2 up 2 over 1, and it's headed towards 1, 3. But then at 1, it switches. And it's a nice flat line. Look, this second line, f of x equals 5, is just a constant. Flat. And this is a good example of how these piecewise functions look. They're going to look like 2 separate graphs, right? At x equals 1, which we knew it was going to be 1 because that's where it switched. At x equals 1 here, we have to the left, we have one graph, the top graph, right? And to the right, we have the other graph, the bottom graph. A nice constant function up here. Okay. Okay. Question. I'll tell you, for the test, I really emphasize this more. The algebraic part more than the graphing the visual part. Okay. So when you're looking at the test, it's more about the algebraic to grasp the concept. Hey, if I'm putting in a certain x value, which of these do I choose? Okay. Which of these 2 do I choose? Okay. Questions? You guys online? Okay. Let's look at let's look at another. Let's look at one that you can kind of make this up, but it's kind of a real one. It's not as much now. I need to really update my real world example, and you'll see why here in a minute. And I've been teaching long enough that it's already evolved. A good example of this is in billing. This happens all the time, right? If you guys have like a cell phone or a cell phone plan that's not like unlimited, or even like your water bill, if you live in Mountain Home, the water bill is set up like this. And even North Arkansas Electric is set up like this as well, where, there's one flat fee for a certain amount. And then if you go over that, it's going to be a certain like additional fee, right? You guys see what I'm saying? So like I used to do this with text messages. That's how old I am. Okay. But before you had to pay like a certain amount for text messages. You got like 2,000 texts for a certain amount. And then you had to pay per text after. Okay. I know, back in the olden days. But now let's look at one that, man, there aren't that many, even like with data now, it's pretty much unlimited. Let's just make one up with data. Okay. Let's say you've got a cell phone plan that gives you, 5 gigs of data. So you get 5 gigs of data for, let's say, $40. Okay. So you pay $40, and this is just your data plan. You pay $40 and you get 5 gigs of data, but then they're going to charge you $15 extra per gig over 5 gigs. Okay, so if you go over your 5 gigs, they're going to charge you $15 extra per gig over 5.
That sounds expensive.
It does sound expensive. I'm making this up. I don't know. I've had an unlimited plan for so long that I don't even remember what it was. But I know now, I mean, now it's like, does anybody have a, I mean, do you guys, I don't even know if they have plans like this anymore. Do you have a plan like this?
Yeah, it's like $45 for 25 gigs.
Holy cow. Okay. Yeah. It's way different now.
Yeah, but after that, it's like half the speed.
Oh, okay.
Everything else
Okay.
charging.
Okay. Let's just do my example from like 10 years ago. Yeah, just because I already wrote it, Caleb. Yeah. So we've got 5 gigs of data for $40. This is fancy data, right? So it costs more. That's what it is. It's the Grey Poupon of data. Okay. So we got 5 gigs of data for $40. Now look, this is piecewise because we've got one function going on. And then if your domain changes, if you go over the gigs, it switches to another equation, right? I mean, I'm trying to think if there's another example of this. Not in billing. Billing's always kind of an easier one to come up with. But I don't know if you guys know of any, if you think of a good one, you can email me. If you find this one in Nature, something like this in Nature, email me when you talk about it. Because I'm always up for updating my examples. Okay. Okay. But let's see how this would look. Let's use C of X as just the cost of our data plan. Cost of the data plan. Okay. And then we'll use X as number of gigs. And I'm going to tell you this isn't perfect because really we're just looking at whole gig usage. Not like, well, what if you use 4.5 gigs? Or what if you use like 6.5 gigs? Like that, it's not usually how it's billed. Okay, but this equation is going to show it as though there's like half gigs of usage, which there are half gigs of usage, of course, but it just kicks you up when you do that. So it's a little made up. Okay, so how would this look? Okay, well, we've got C of X equals, right? And we know it's going to be $40 as long as we stay under 5 gigs, right? So I'm going to even write this as money. It's going to be $40 if, now we could be equal to 5 gigs, right? If we stay less than or equal to 5 gigs, we're at $40. Okay, and that makes sense. Look, if I use 1 gig, $40, right? Because one goes. If I use 4 gigs, $40. Okay. Now I'm going to come up with the equation for the second part, the 50 extra per gig over 5. You can try this. It's just not going to be part of the test. Okay, let's see. If I was going to create the next equation, well, we'd have to start with the $40, right? Actually, I'm going to drop the $sign because it's going to get a little crazier. We have to start with 40 because we've already paid for the first 5 gigs, right? So that's $40 plus it's going to be 15, right? We said it was $15 times, it wouldn't be X because you already paid for the first 5 of those X's, right? So it's any X value over 5. So it's going to be X.
X minus 5.
Yes, ma'am. Whoever said that. It is harder to hear you guys in that because it's down here on my, you guys can't see any of this. I don't know why I'm pointing at it, but it's down here on my laptop and not up here on the speaker. But yeah, whoever said that, you're exactly correct. It's X minus 5. Now this is going to be if our X value is greater than 5, right? So we created an equation, and this is what they do in billing departments and tech departments, right? They create the equations to pop out your bill, right? They are just the messenger. Don't get mad at them, but this is what they do, and then they code this, right? They code it where okay, Kylie uses 6 gigs. Oh, bloop, 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 bloop. We put it into here, right? It's this. It goes into this equation, not that one, because it's an if-then statement. So if Kylie uses 6 gigs, oh, this is less than 5, or 6 is not less than 5. we don't use that equation. We go to this one. Oh, now we plug it into here, and then it pops out what her bill is going to be. Okay, kind of neat. It's all behind the scenes. It's all automated, of course, but on a very basic level, this is where it's coming from. Okay, so let's do that. Let's say Kylie uses 6 gigs of data. Oh, she went over. Forgot to hit that Wi-Fi button. We get 40 plus 15, and then times 6 minus 5, right? Oh, this isn't bad. 6 minus 5 is 1. We only went over. This is that math whenever students are like, well, I can do that in my head. Why do I need to do it on paper? I get it, because it's a real world example. But I'll tell you, that same student would say, I hate word problems. Well, what am I going to do, right? If those questions, when you're like, well, I can do that in my head, it's easy. If she did 6 gigs, we know it's $40 plus 15, right? It makes sense. But then also, that's a word problem, right? Life is just word problems. That's all it is, okay? Except in this class. And for a lot of you, once the class is over, there's no more non-word problems, right? It's a lot of just real life issues, real life problems. Okay, anyway, my rant's done there. So 40 plus 15. So we do wind up with what, $55? Okay. So her bill minus the $10 in fees and $20 in taxes is going to be $55, right? Okay. So now let's say someone else came along, and since I've only got 2 in here, let's say Kayla comes along and makes sure to hit her Wi-Fi button. And so she only uses 2 gigs a day. She's at the college, which has Wi-Fi, at work has Wi-Fi, home's got Wi-Fi. So she only uses 2 gigs of data from listening to her favorite podcasts on the drive to and from work and school, okay? Well, we know since x equals 2, if we go the equation route, 2 is less than or equal to 5. Hey, it's going to charge her 40. I mean, really, in a way, Kylie up here got a better deal, right? Yeah. I mean, she's really charged almost less than $10 a gig. But because Kayla only used 2 gigs of data, I mean, it costs her $20 a gig, right? Kind of interesting to think of it that way. Okay. Okay, so then, of course, Mr. Shirley comes along, and he is really bad about hitting the Wi-Fi, and he uses a ton of data while he's listening to Spotify all day and playing games on your phone would probably do it. I don't play a lot of games. Let's assume I play a lot of games on the phone. So, and he uses $40 worth of data, or 40 gigs. You think 40 gigs would be hard to get to?
I don't know.
Like if you watch Netflix on your phone, you know?
It would be easy if you do a lot.
If you do a lot of stuff, if you play games and then like watch Netflix on your phone, I think you can get to 40. I don't know. And it's, yeah, and there's a lot of people that don't have Wi-Fi at the house, especially around here. So it would make sense that if you did all of your interneting on your phone, you might be able to get to 40. And if you're watching Mr. Shirley teach a math class on your phone, it might get you to 40 quicker, right? So let's see how much that'll cost. Again, it's going to be on the second one, right? We did not stay under our 5 gig. Okay, 40 plus 15 times 40 minus 5, right? Okay, I'm going to need a calculator. So we'd have 40 plus, now that's 35. So 15 times 35. That's the times. So 40 plus 15 times 35. 525. Did you get that too? Holy cow. Miss Shirley is not going to be happy with that. Okay. And oh God. Exactly. I spent my stimulus money on my cell phone bill, stimulating that side of the economy. Oh, you know what? Now that you bring up stimulus, now the stimulus in a way was like this, and so are your taxes, because your taxes are a graduated plan, right? Where everybody pays like a certain amount of tax for one level, but then when you go up a level, it's like you don't pay it's not your entire amount you've earned at that next level. It's, whatever at the bottom in that gap. Oh, that's a horrible way of explaining that. I apologize. But if I've got time one day, I'll explain how tax brackets work. But yeah, like if the top earner bracket's like 60%, it's not like that all of their taxes are taxed at 60%. It's graduated up to 60.
Don't you still have to add 40 to? Don't you still have to add $40
Oh,
to
did
the?
you guys not add the 40? Did you add the 40? Oh, okay. I'm sorry, guys. So 60. There we go. 565. Don't forget the 40. The cell phone company will not. Okay. No, they won't. Okay. These are two really good examples. One's a real world and one's more like you'll see on the test. Do you guys have any questions in the class? Do you guys have any questions in the Zoom world? I'll give you a minute. I feel like even the video's not as good as it usually is. I don't know what's going on. Yes, usually I can play with it. I mean, I just don't know the audio part.
That would overwhelm me. One day in Miss Knox's class, she let us take turns being the teacher and setting all this up because she was getting real sick of it.
I like her mind though. Like, oh, we'll let you guys.
You're gonna be teachers, so you should learn how to do this.
Oh, that's beautiful.
It was so hard.
And you know what I've noticed, and like today, guys, and I know you guys didn't see this if you're on the online class. Oh, well, Alex, we're going to go over all that. I got here kind of early. I mean, not super early. And I like quickly set it up and I'm like, oh, feeling all confident. This is going to be easy. I'm excited. And then of course this happens. Okay, so I just have some additional homework from the last class. So the last class I already gave you some homework. I'm going to just give you the piecewise questions now. And it's not that many. It's only 37 through 41. So in 2.1, actually, I'm going to give you all these. And 2.2, I'm sorry. 2.2, page 40. There's just a few extra questions. Oh my gosh, page 240. 240. Numbers 37 through 42. And if you want to do the odd, that's fine. Each one of those has an ABC component. So if you want to do odd, that's fine. But those are the piecewise functions, and that's how they'll look on the test. Okay.